So what I'm introducing is the formula gradient of A equal to 0. Okay, so I'm gonna prove it, and this is known as Coulomb gauge condition. This condition is used in the context of magnetostatics and simplifies the equations involving the magnetic vector potential A vector. To explain this in detail, I want to proceed in 4 steps. So the first step is magnetic field and the vector potential. As the course mentioned before, we just use B vector equal to curl of A. So the magnetic field B is expressed in terms of the vector potential A. This relation comes from the fact that the magnetic field is divergence free. Okay, so now I want to introduce a second step, which is Gauss's law for magnetism. Gauss's law for magnetism says that the divergence of magnetic field is 0. So yeah, you can see that divergence of B is equals to 0, and we know that B vector is equal to curl of A. So we put this into the second equation. We got this. Curl of B is equal to divergence of B is equal to divergence of curl of A. And the third one is divergence of a curl. From vector calculus, we know that there's a mathematical identity, which is divergence of curl of A is equal to 0. So we know divergence B is 0 because this one is 0. Okay, and then we're going to introducing Coulomb gauge. The vector potential A is not unique because there is a gauge freedom that allows for different A vector fields producing the same magnetic field B. To make calculation more simplifier, we impose a condition called the Coulomb gauge. Coulomb gauge, which is the same as here. Yeah, and we just set it as divergence of divergence of A equals to 0. And why is this useful? Because this one simplifies the equations governing the magnetic vector potential A vector, and particularly when solving Maxwell's equations in magnetostatics. And by choosing divergence of A equals to 0, we can eliminate unnecessary degrees of freedom, making solutions for A vector unique and easier to handle. So we just got this summary. Yeah, right. Divergence of A is equal to 0, and consistent with the fact the divergence of the magnetic field B is equal to 0. Yeah, so it's my presentation about the gauge condition. Okay.